So for number 75, you have to read the definition that's given for a perfect number. It's a natural number that is equal to the sum of its factors. Excluding the number itself. So it says determine if the number given is a perfect number. So you're looking at, in this particular problem, it's the number 28. And so let me write that, add this in the excluding itself. Now this is not just talking about the prime factors, it's any factor. That's why it says excluding itself in there. So if you look at the factors of 28, this is where I might start a chart, especially if you took me for intermediate algebra, you're used to this chart. You'd say 1 times 28, and then 2 times 14. Does 3 go into 28? No, so we skip it. So 4 times 7. Does 5 go into 28? Does 6? No. And 7 is already in the list. So that's how I know I have all the factors of 28, if I do them in order that way. Now, if I add up all of the factors excluding itself, so I'm not going to include 28. So I want to add 1 plus 2 plus 4 plus 7 plus 14. So then here I've got 3 plus 4, which is 7. 7 plus 7 is 14. And 14 plus 14 is 28. So the sum of the factors excluding itself did equal 28. And so therefore it is a perfect number. So these types of problems that you see towards the end of the homework sets, they're intended for you to sort of take things a little outside the box. So based on what you learned about factors and so on, how can you take that and apply it in a different way? So that's what, when you get to the ends of each of the homework sets, you always have a couple questions that will make you think a little bit differently. Now number 91 I'm not going to do yet because that is part of what I'm going to teach the rest of 5.1 today. So hopefully after today's lesson it'll make much more sense. Okay, so we're going to continue in section 5.1 where we left off. Okay, so last time we talked about how to get the prime factorization of a number, and this leads us into finding the greatest common divisor, or the otherwise known as the GCD. So the GCD is the largest number that divides into a given list of numbers. Some of you guys are sort of familiar with the GCD because it's the same process you have to take to find the LCD, the least common denominator. Very similar acronym. But you're looking for the largest number that divides into a given list of numbers. So don't confuse these acronyms, though, because they're not exactly the same process. So to find the GCD, and you'll learn that I'm a very step-by-step type teacher. I like to give you step 1, step 2, step 3. And there is more than one way to do these things, but I just like to give the most systematic way. The first thing that you can do is write the prime factorization of each number. And then select each prime factor that is common to each factorization. Use the smallest exponent. And then once you've done that, just multiply the factors from step 2. So let's say that you wanted to find the GCD of 225 and 825. Now keep in mind that you're looking for a number that divides into both of these numbers, so if you want to make a little side note that the GCD is either going to be equal to the smallest number in the list or smaller than that number in order to be able to divide into it. Okay, so it's going to be less than or equal to the smallest number in the list. You could actually put that as a note by the definition. Okay, less than or equal to the smallest number in the list. So the first thing that you want to do is find the prime factorization of each of these two numbers. So I'm going to go ahead and let you get started on each of those if you want to do the tree factorization method or whatever it is. So this is a little bit of a review of what we did last time. So find that prime factorization of each number. Remember, when you're doing prime factorization, or you're doing the tree factorization, it doesn't matter which two numbers you start with. You'll eventually get to the same prime factorization. And just remember to try to do these without a calculator, because you won't be allowed a calculator on the test. But when I look at 225, sometimes you can get things that'll make it a little easy too. I think this looks like $2.25, and so the number 25 goes into it. And if you think along the lines of money, most of you guys know your money a lot better than you just know numbers. And you know how many quarters are in $2.25. So how many quarters are in there? Well, in $2 there is 8, so one more would be $2.25. So that's 8 times 25. Just some little hints that can help you with these numbers, being that you don't have a calculator. And you might have started with the number 5, and that's perfectly fine. So whatever makes it easier for you. So then 8 is 2 times 4, and 4 is 2 times 2, and 25 is 5 times 5. So the prime factorization of 225 equals 2 cubed, good, times 5 squared. So we have 3 2's and 2 5's, so 2 cubed times 5 squared. So now looking at 825, I can also use 25 in that if you wish, or you can use... You're right, because I said it's 8 and then one more. Sorry, in my head, I didn't go further. Feel free to correct me sooner if you saw it. Okay, so that's 3 times 3, but thank you for making sure to correct me before we kept going. So 3 squared would be our new number there. And so now over here, if you didn't want to use 25, and maybe you didn't use 25, you could have used 5 on this one. And 5 goes in, let's see, 1 time, and then 6, and then 5. Did I do that one right? Okay. And then 5 goes into this again, 33, okay? And then 33 is 3 and 11. Okay, so for 825, 3 times 5 squared times 11 is correct. Now, you didn't have to write them vertically like this, but there's a reason why I did that. I wrote one right under the other, because in step 2 it says, select each prime factor that is common to each factorization. So now I'm going to compare these two lists, and say again? Okay, so now I'm going to look at these two lists, and for my GCD, I want to choose any of the factors that they have in common. So they both have a 3, and they both have a 5. And then I'm going to look at their exponents, and it says use the smallest exponent. So between 3 squared and 3 to the first, 3 to the first is the smaller one. 5 squared and 5 squared, that's both the same, so we're going to use 5 squared. So those are all the factors that they have in common. And now just multiply this out, and you have 3 times 25, which equals 75. So 75 is the GCD of 225 and 825. That is the largest number that will divide into both of those numbers evenly. This is the smallest number that is divisible by a given list of numbers. And this is the acronym that is actually the same as your least common denominator. So LCM, LCD are actually the same thing. The smallest number that is divisible by a given list of numbers. Now, even though we have the word smallest and the word largest, this time your least common multiple is going to be either the same or greater than, so greater than or equal to the largest number in the list. It can't be smaller than the largest number in the list, or else that larger number won't be able to divide into it. So step 1 is the same. You're going to write the prime factorization of each number. But for step 2, instead of writing what they have in common, this time you're going to write down every prime number listed. You want to include all of the factors that are listed. And then this time use the largest exponent if they do have numbers in common. And then multiply the factors from step 2. So here's our example. Find the LCM of 18 and 30. So the smallest number that's divisible by 18 and 30. Now, if the numbers are real small, that's not hard to do in your head, but these steps will allow you to know what to do when the numbers do get a little larger. So I'm going to go ahead and work through each of the steps so you learn that process. So the first thing is to find the prime factorization of each number. So 18 is 2 times 9, and 9 is 3 times 3. And then 30 is 3 times 10, and 10 is 2 times 5. So we have 18, which equals 2 times 3 squared, and 30, which equals 2 times 3 times 5. So any questions on the factorization itself? All right, so this time, instead of selecting what they have just in common, you want to write down every single factor that's used. So for your LCM, we need a 2, we need a 3, and we need a 5. And then this time you want the largest exponent. Well, 2, the largest exponent is a 1. On the factor of 3, the largest exponent is squared, the 2, and then 5 is just 5 there. And now multiply all the numbers that you have. So you have 2 times 9 times 5, which equals 90. Whoops, not LCD, LCM. So the smallest number that 18 and 30 divide into is the number 90.